Hey guys, welcome back to Lane the Project Guy. This is part 2 in our series on making the brake shoes for our Northern 484 live steam locomotive. This locomotive is built in 3/4 inch scale, and I'll be able to ride on this locomotive. It'll burn coal, boil the water, and operate just like a prototype locomotive. Today, our video concerns making these brake shoes. I have here the plans blown up for you to see. But this was a very complicated project. It involved a lot of processes and had been troubling me for several months as to how I was going to accomplish this. But we got it done, and look forward to having you look at the video and see how we got these things made.
Okay, this is just a shot I thought was pretty of the brake shoes in process. First step today is to center up our rotary table and then center up the blank on top of the rotary table. It's kind of a cool way to do it, isn't it? Now we need to drill our pin holes. These are the holes that will have a drive-in fit pin, and that's where the brake shoes will mount to the hangers. And I decided to use the rotary table to its full effect to do this. Rather than changing tools constantly, I decided to stick with one tool and change positions. So I'm spotting my holes, and I'm using the paper template, but more importantly, I'm actually moving the table the prescribed number of degrees in order to position these holes. So it's 45 degrees movement between each hole. And now I've changed over to the drill bit. You can see there's some oil there on the paper with 3 holes. That's where I practiced my drill bit and reamer combination to get a drive fit for my pins. Remember that drill bits are not a precision instrument. They can flex, they wear, they get dull. So the hole they drill is not precision. It's fairly coarse and off size. It's your reamer that gives you the precision. So we have to drill 8 of these holes. Of course, being careful not to go all the way through to and tap the rotary table. I've got the blank suspended on some aluminum block or steel blocks, and I have the stop set on my down feed so I can't hit the table. So now I got the reamer loaded up, slowed the mill down, and going through and going to ream all 8 holes. There's a lock there in my left hand, and turn the table with the right hand, and then you got to lock it down so it doesn't move when you start working on the blank. Just show you a couple of these all day long. You know, it's 8 steps and everything because you're making 8 brake shoes. So I really compressed this video. This is probably about a 3-day process, to be honest with you, to make these brake shoes. But found me a horizontal reference and then put in a fairly large 4-flute end mill and started just kind of gnawing away at the blank. This is just a material removal process here. Speed it up. And at this point, I'm relying heavily on this paper pattern that I've glued to the blank. It turns out to be something that's not going to work for me, but for right now, I'm relying heavily on it. Taking 25 thousandths a pass. This isn't a terribly rigid setup that I've got, so even though this mill could really take much bigger passes, I'm afraid of disturbing my setup. Starting to realize the paper is a cumbersome process here and trying to figure out a better method. I cut it away and thought, well, I'll just use it right here at the end. But as I put oil on the blank, it's dissolving the glue. It's just the paper is becoming more and more of a problem. This is your moment of meditation. Nothing a machinist likes better than to watch a pass with chips flying. All right, you can see we've milled away quite a bit of the material. Now I'm finding me a vertical reference. So I've got a gauge block. I'm going to clamp up there, and I'm just trying to get an eyeball on a vertical reference. I think I have it already, and I'm just making sure that I am on it. So I just run the mill down and kind of look at the shadow, how much light is coming through, and confirm that this makes sense to me. And start making those 25 thousandths passes again, dealing with the paper. Probably is a 15-minute process compressed to 1 minute for you. Moving down vertically and now going across horizontally to get to my line. Once I get to the line, I zero out my DRO, and my plan is to use that reference point with all the brake shoes. I'm hoping that's going to work for me. But when I laid out this paper pattern, I did it by hand and just used a compass and made me some lines. Just tried to center them all up. Then went over to the copier and made a master copy. But it wasn't precise when you're talking about within thousandths. And I'm kind of starting to realize it as I'm working on this. My DRO's not winding up in the same spot with each brake shoe, and my brain's starting to get frustrated with the paper. So I'm thinking of a solution in the back of my mind at this point, and decided to make me a little tin pattern. So that's a piece of tin with another brake shoe pattern glued to it. And now I've put some Dicom on my blank, and I'm going to pin it down with that reference hole. Use my inside circumference as a reference, and I'm going to scratch out each of these brake shoes onto here and be done with the paper. And this really should have been done at the beginning. It just takes a while to work it out in your mind how you're going to do it. And I guess that's why when you do something the second time, it goes much faster than the first time. There we have it all drawn out nicely, and we're done with the paper. Now the issue is getting it set back up in our chuck so that it's referenced like it was before. There's multiple problems with this. There's that nut on the back is my actual lock. This is like a quick release lock to get you in position, and then you fasten the nut to really tighten it down. And just eyeballing it, trying to get it lined back up. You know, some of these jaws are in the way, so I had to move this twice during the milling process. Turn it counterclockwise to move those jaws outward, cinch it down. I want you to look at that quick release. See it moving there? It's because I didn't tighten down the nut on the right, which is really a mistake. So I wound up with one shoe that was off by a few degrees on the angle. Didn't realize it at this point. I'm dumb to that. And I didn't know why it had happened until I started making this video and saw that. I was glad I caught that. Here we go, just separating our 8 shoes from each other. I know in episode 1 people were asking, you know, what the heck's going on with this blank? How are you going to make 8 shoes out of this blank? And I'm sure it's making sense to you now. My little finger stuck straight out. If my brother's watching this, put in the comments section why my little finger doesn't bend. He's the only guy that would know, so we'll see if he watches the videos to completion. He says he does, but hey, Bubba, if you're out there, put a comment in as to what happened to my little finger. And getting the shank milled down to size. You can see faintly see the line that I scratched on there earlier with the pattern. And I have lost one of the flutes to the mill at this point and to the tool. I don't even realize it. The mill's got a vibration in it that I'm not accustomed. Excuse me, I'm not accustomed to, and I didn't even realize why. I pressed on. I thought my ways were loose. I kept tightening that, and even at this point, I've still got that same tool in there. And I don't know if you'll catch a glimpse of it, but it's down to one flute. I've lost a flute. It's only working because I'm taking these real shallow passes. And I'm taking the shallow passes because I think my setup is so flimsy. But in reality, I had a out of balance tool. I'll know better in the future. I'll recognize that sound. But move over to the vise and the soft jaws and start filing. And I want to encourage you to buy you some copper and convert your vise jaws from steel over to copper. It is so useful. I thought I'd swap them back and forth, but I stick with the copper all the time. It's so easy on, doesn't scratch, doesn't dent, and it holds things nicely, except for that that one wiggle you saw there. I had to file 8 of these. Guys, you can imagine, this was probably 3 hours of filing compressed to a minute or two of video. Filing is an art, and it leaves a wonderful finish, and it's a fairly precise process once you get good at it. All right, so back to the milling machine. I've got a drill bit down through my reference holes where the pin would go, holding them all together, and I'm trying to make them symmetrical. It was harder than it should have been. I had to take more material off than I originally planned, and it was because I had that one shoe, which was the shank was a few degrees off, and I actually had to decide, am I going to take enough material off to make them all perfectly symmetrical, or am I just going to get close? And I decided to get close. My shank was getting thin. I was right on dimension, and I didn't want to, but you can see that one right in the middle. It's like a snaggle tooth, and that's because that indexing head jumped on me. But I just think I made a smart decision to let that one be a few thousandths off. So at this point, I was starting to think, I'm taking a lot of material off of here, and I'm getting really, really close to exceeding the dimensions in the plans. And so I decided to finish this pass and call it quits on that process. This was kind of fun, watching those chips spin off to the right and everything start lining up. Two drill bits in it right now. You can see I've got one down the center hole, and then I've got one up there in that groove I just milled, and that's holding everything really good in alignment. At this point, my heart's racing. I'm liking the way it looks and just praying that I don't lose this setup. I kept thinking, if this tool grabs and spins these things out of alignment, gouges everything, I'm going to be in a mess, because I am almost done with several days worth of work. Pretty OCD about keeping my chips vacuumed up. Keep that vacuum handy and clean just about every cut I vacuum. So now it's over to the belt sander, and the belt sander really made them look nice. I had a concern. I have that groove that's supposed to simulate the brake pad. I didn't want to sand them so far, so deep that I was lost that groove. So I really just hitting them and polishing them up, getting rid of the tooling marks. And of course they get hot, so I have to keep dipping it in water. But it's a good way to use this belt sander, horizontal like that, and use that stop. And boy, it just polished them up nice. Now I've got to drill the hole in the shank, and I wanted a repeatable setup so I wouldn't have to find the location of the hole 8 times. So I've got this stop in the vise, and I'm trying to come up with a way to make a repeatable setup. Now that I think I've got that figured out, I'm going to find my reference point. It's that hole we drilled initially in the blank, and I need to find the center. So I'm using this center finder, or edge finder I should say, that I bought just a few months ago, and I got away from the the wiggler slash wobblers, and started using this electric one, and gosh, it's quicker. With the wiggler, I would find the edge probably 3 times to make sure I was basically had an average. With this one, I've discovered I only need to do it once. It's the same every time. Now I've got a gauge pin in, and I'm just trying to do a sanity check and make sure I like the way the hole's going to look. So I kind of kiss it 2 or 3 times to put a little bit of an etch in the metal, and I can see what the hole's going to look like. I'm double checking to make sure that the hole's in the right spot according to the plans. This took a little math. You have to add the radius of your 2 pins, and you subtract the radius. That gets you to the center of the pins, and then you look and see if you're, center to center is what the plans are saying. So you got one done over to the right. This is number 2, and once again, this is kind of a sanity check to make sure the repeatability is there for me, and it was. I'm debating right now whether I'm going to leave that plate in there or not. I don't want this brake shoe to rotate even a degree, so I decided to leave it in there for at least the top hole. And once again, to the art of drilling, it's kind of a pecking operation. If you just pull down on the feed, you're going to dull your bit and possibly move your brake shoe out of position. So I put some cutting oil on there, and if I see the cutting oil start smoking, I know I'm getting hot. I back off, put a little more cutting oil, let the tool cool down. I think beginners would just punch it through there, and after you've done 1 or 2, your bit's going to be dull, and then you start punching harder, and everything starts going crazy on you. This is a very light touch here because I don't have my plate in there stabilizing things anymore, but it worked out really nice. I did 8 of them, went fairly quick. It was very repeatable. Hole looks symmetrical. I was worried about going through there at an angle and winding up close to the edge on the bottom. So I did this in the vise, really. This is just for the camera, just deburring. It looks awkward holding it out there in front of you at arm's length, but I was kind of proving this is what I'm doing. But in reality, I took the other 7 over to the vise and did that. And they're really looking nice. There's one more process, if you can guess what it is. Look at that. That's where my tool broke. I lost the flute and it spun off and gouged my shoe, and I just saw that as I was shooting that that clip. I'll put that to the inside on the locomotive and no one will ever see it. So this is the last process. I was asking you to guess what it's going to be, and I've got a file or radius on those shanks, and I decided to not do it with a belt sander. I didn't think that would be repeatable 8 times, so I'm making a filing button. I've never done this before. I've read about it, and it's a simple process. It makes sense. So I've got my diameter I want is 300 thousandths. Should be doing this with a micrometer, but it doesn't have to be that precise. I get 301. That's well within what I need. You got to know when to concentrate on precision and when to just keep moving. I hold my shank up there on the brake shoe just to make sure that makes sense. And there's my button. Got a small end that's going to go into the hole. The large end is what I'm filing to as my guide. So now it's time to harden it. So we're going to heat it up cherry red, my little homemade kiln here. And the fire bricks have a purpose. They hold the heat in, and it's almost impossible to do this without the fire bricks. So go ahead and buy you some of those. Drop it into water or oil. It'll freeze the molecules in a crazy position, in their excited position, and make it as hard as glass. And you start filing. You see how that works. Just drop it in the hole, and I'm going to file down to it. And it's harder than my brake shoe steel. So once I get down to it, the file should quit being effective. And this took a lot of repositioning in the vise, and you had to file the upper shank section and the lower shank section on each one. So basically, you had 16 processes, each one taking probably 10 minutes, 160 minutes. I mean, it's 2.5 hours of filing compressed into 1 minute for your enjoyment. But you can see why I tell people this locomotive is a decade project. But look how nice that looks. It is no better sense of satisfaction than winding up with 8 parts that all look just alike. It looks like they came out of a factory. You know it's going to look good on the locomotive. I was so proud of it. There they are, all finished. I love that little curve on the front that I filed into them. It makes them look very custom. And subscribe to Lang the Project Guy. We need you. Glad you stuck around to the end. Thanks so much.